I'll start anyway. Hi, I'm Bob Kibble, and I've been waiting to speak to you all. A very warm welcome this morning from Scotland, and I'm going to be enjoying spending some time with you. Probably the very first time I've spoken with teachers in South America, and particularly teachers in Argentina. So best wishes from Scotland to all my friends and future friends in Argentina. I'm speaking from my hometown, which is called Peebles in Scotland, and it's, as you see, it's a very beautiful place. It's in the countryside, and that's the River Tweed, very famous for salmon fishing, running through the town. We have autumn colours, rather like this photograph at the moment. It's a very beautiful time of year, and I hope one day maybe some of you will have a chance and have the good fortune to travel and visit places in Scotland. A big thank you to Charlotte. Charlotte, thank you very much. I enjoyed your session very much. There were things that you've mentioned which I'll pick up on here with the language of science. And a big thank you to Silvana and the team at ESARP, and of course Macmillan and all of their team, Rainer and Mariella, have managed to put this conference together. So it's a real pleasure for me to speak to you. Now, I know very little about educational challenges in Argentina and South America, but I've done some reading, and I think you're actually going through quite a change, I would guess. A change which probably some of these issues would resonate with you. I know that there are national standards, sometimes called priority learning guidelines, I believe, and you're learning to cope with these and to move forward with these against other initiatives. And of course, we're all dealing with COVID-19 and the possibility of blended learning, with some children learning at home and some children learning. Sorry, I've just got a message. Thank you very much. Okay, and some children are learning at school, or some people, of course, are learning both at home and then at school. So I'll say a little something about blended learning. And I hope the microphone is stable enough for you to hear me. So my targets for this presentation include a reference to your learning journey. And I'm not, as the title suggests, going to focus only on inquiry skills. And I'm doing that for a special reason, because this is possibly the only time we'll have a chance to talk to each other. I think there are some very important messages I want to share with you as a teaching professional to other professionals, because you are on a journey, and as we all are as teachers, on a learning journey. And I have been on a journey for about 40 years. And our teaching will change, and our outlook changes, and our values even change as we learn from conferences, from watching other teachers, from new initiatives. So the journey that you're on, I want to make reference to. I also want to talk a little bit about how Max Science can help you with the special challenge of blended learning. So I'll say something about that around about midway through this presentation. And finally, I'm going to, of course, tackle the challenge of inquiry in science education and make reference to how a publication like Max Science could really help you as teachers with your children and the process of inquiry. So, as far as I can read, the national standards make reference to improving scientific literacy for all learners, to engage with pedagogies which are inquiry-based, a lot more hands-on, focused on finding out. And I think for you as teachers, you're on the journey of moving from what I would call a teacher perspective to a learning perspective. And it's a journey that you're not alone on. because in the UK, we've all been on that same journey. I've been on that journey. And I know that across the world, the other education systems that I know of and their initiatives are all sending their teachers on this same journey. And these two photographs, I think, summarize that journey. On the left, well, that's traditional teaching as it was in 1950, perhaps in school when I was a boy. And on the right is modern teaching. And what do we notice there? There are certain differences. Of course, on the left-hand side, we've got children listening to the teacher. The teacher's word is critical. The teacher has the teacher's desk. The teacher's standing. The children are sitting. The children are silent. It's a well-behaved class. A modern teacher on the right-hand side, well, she's kneeling. The children are in a group. They're working collaboratively. The teacher is listening to the children. Her words are not important. They're not important. They're not as important as the children's words. And moving from teaching to learning is summarized, I think, by this slide. We'll talk a little bit about that journey for you. And I like this slide because it summarizes what I think I've tried to do in Max Science, and I know as a teacher educator I've been trying to do with my student teachers in producing teachers for the future. Here we have a conversation between a parent and a child at home. It's going to be about school. Well, of course, this is the sort of thing that may be said. What did you do at school today? Ah, we mixed sugar with water. Ah, the conversation continues. What did you learn? Well, we learned that we could mix sugar with water. Oh yeah, but why did you do this? Well, that's what the teacher told us to do. We had fun and we tidied everything away. Now, if you recognize this as your teaching, I wouldn't worry about it because lots of us have been down this path. We've got to move on and we've got to learn to move on from this. But being able to count all of the rulers back in and make sure everything's tidy by the end of the lesson, of course, we have to do that. We have to make sure everyone is engaged. We have to do that. But our job is so much more than that. This is my hope for our teaching, yours and mine, in the future. Ah, we mix sugar with water. Oh, what did you learn? And that's the goal. And that is what I think scientific literacy means. It means children's voices being engaged, thinking about ideas, and displaying an understanding through language. And that's why the science session today with me is so importantly linked to the literacy and language sessions from Charlotte. Good science teaching is about empowering children to think and to talk. And your job as a teacher mostly is to listen and to encourage their teaching, the teaching of you, in fact. And for me, Max Science is based on learning for understanding, and learning for understanding is about speaking the stories, what I call the stories of science. And here's one of the most important stories of science on the screen here. The story about particles, all things made of particles. It's a story about imagination, about things you can't see. But we can talk about them, just like we can talk about the Jabberwocky, or Harry Potter, or other made-up stories. Children have immense imaginations, so there's no reason why they can't think about the story of particles in a beaker of water, or in a puddle that evaporates, or in a cube of sugar which dissolves. And so to summarize this movement that I feel is your own professional development movement under the national priorities, will be to move from a situation where you feel you have to do all the talking. Move away from that. You have to learn to do this, by the way, to stay young and live longer. If you do all the talking in lessons, you'll soon run out of breath, run out of steam, and run out of puff. You've got to learn to listen. So listen to children, ask them what's happening, then listen to their responses. Their voices are more important than yours. And I think that's the most important thing I'll say to you today. Children's voices are more important than yours. And have them speak to each other. Have them speak to their friends. You don't have to listen all the time. As long as they're speaking about science, they're learning science. They'll be thinking and articulating. They'll be telling their own science stories. So there you are. Your professional journey is to remain a student of learners and their own learning. So that's what I have to say about the situation where science education through national priorities moves people from a more traditional teacher-centred style through to a more modern learner-focused style of teaching, where children's voices are critical. Children's questions are to be celebrated. And you will live longer if you learn to do this, I promise. I'm only 32, of course, and look at me now. Now, of course, I'm living longer, thankfully, because I'm being looked after well by my wife. Okay, so to Max Science. I was the chief editor for Max Science, and I'm very proud to produce this whole suite of books for science education for primary learners. And I'm going to introduce you to the family of Max Science now, because you may not know what is on the horizon for you, should you embrace, or your school embrace, Max Science materials. Of course, there's a very good in full colour science student book, which is the textbook, and there are 6 of these throughout the whole of the course. And they are full of experiments and activities for children to do. They have language support, they have self-assessment questions, they have end of topic assessment questions, and they are completely engaging. And it's very easy to navigate your way through a Max Science page. The student book is supported by a workbook. Now, the workbook is not in full colour, it's in 2 colours, but it's the workbook that is the children's own book. It's the book they take away with their name on it. It's their evidence of learning. So their answers will go in the workbook, and they can be proud to show you the workbook at home or at school. The third member of our family is the journal, and the journal is a critical bridge between home and school. And as you know, learning doesn't end at the end of school day. Learning happens throughout life, and learning can often happen at home, in a home context, and learning might happen when a child at home is talking to a parent, or a guardian, or a brother or sister or uncle or grandparents. The journal links that home learning conversation with what's happened in school. So the listener, the guardian, the parent will have no trouble in finding out what happened at school today, because the journal gives them an entry into what happened at school. And one of the lovely things about the journal is it encourages children at home to explain their ideas to folk at home. So children, once they're at home, will be encouraged with the questions in the journal to find an adult and to explain the idea of particles, or the idea of growth and seeds and cycles of life, or the ideas of the solar system, or how we see things, or whatever is on the science topic for that week. So the journal is a critical bridge between home and school. And of course, during these difficult times, the journal could be a critical device and friend for helping to bridge that gap from school to home if children are home learning. Of course, one of the other important things, as was mentioned in the storybook video just now, there is a teacher's book, and we've written this with every single best idea we could possibly put together about good teaching and learning. And it's all in the series of 6 teachers' books, which support every single activity. And also, Macmillan have produced a teacher presentation kit, which is an electronic resource with all of the Max Science facilities and more. So if you want to contact your children electronically or have them do some work if they have access to computers, or even if you're at school and you want to draw on a computer animated element of teaching, then you can use the TPK. And the TPK has all of the student book material, references to syllabuses, references to skills sheets. Here's one about conclusions. It has additional very good quality graphics that you can use, flashcards with keywords and phrases, and it also has audio file as well, where pronunciation of key science words is supported by a clear articulated word or phrase, so children can listen and repeat. And that's the TPK, which completes the package of the family of Max Science materials. So I often think of the TPK not being a whole course, but being another dimension of our program. But of course, in today's challenges, that dimension could be quite critical. You may have children isolating at home or needing to work during some part of the week at home. Or you may want to set particular tasks for differentiated groups of learners. You may want to target some skills, or you may want to engage children in self-assessment at home. In such blended learning situations between school and home, the journal will become part of the critical bridge, but so would the TPK. It's an extra dimension for you as a teacher to help you manage planning learning. And so I want to move to science inquiry. This is one of my favourite images taken from children inquiring in their science lesson in China. The sense of wonder is quite evident in this picture. And also the fact that these children, they're doing science without the teacher on their shoulders. They're actually working collaboratively in a small group, and they're using very simple equipment, a drinking straw and a plastic cup and some coloured water. And they're looking at dissolving. And it's an amazing thing that they're doing. They're of course observing, and they're practicing a critical science skill. And they'll no doubt report on their observations a little later. They'll observe and they'll report. I often think of the challenge of inquiry in science as the joy of finding out. But of course, it's not just the children finding out, it's you and them, the whole of the class finding out together. So the joy of finding out is something you can share. And I'm sharing the joy of finding out with this particular group in China. And of course, I'm listening to them and thinking as a teacher. Because when you're finding out with children, these are the sorts of things that might be happening. You're listening and you're promoting, thinking, why did you choose this one? Why did you think that? You're asking open questions, because open questions will lead to extended, thoughtful answers. And thoughtful answers is where children start to tell their own science stories. And if you listen to their stories, you'll know whether they have the idea you wish them to develop, or whether you need to mould and re-steer and realign. But only if you listen to them will you have a clue about what they're really learning and what they're really thinking. So that's the power of science inquiry. It gives you an inroad into their thinking. So who's the learner in this situation? Well, I'll tell you, I think I'm learning as much about these children as they are learning about science. And that's critical for me as a teacher. Now I'm going to have a look at two areas of science inquiry, two practical tasks, because one way to think about science inquiry is to have hands-on activities with brains-on activities alongside. So you're doing, but you're thinking and talking about what you're doing, just like the previous slide. In Max Science Level 3, we tackle the subject of forces and motion. I think forces and motion will be in most primary courses. And Level 3 textbook runs through 4 different areas, starting off with a review of earlier work on forces, simple reference to pushing and pulling with some easy materials to orientate children to what they've learnt before. Then we introduce the idea of measuring forces with a force meter measured in newtons. And then we have a look at forces which start and stop movement. And finally, we'll have a look at things that slow down through friction and how that can be really useful or it can be very difficult for us. So that's how forces and motion appears in Level 3. And we'll take this as a topic to have a look at more closely. Now, this is not from Max Science. This is from a publication I wrote some time ago, but I want to share it with you for 2 reasons. One is it starts the story of forces for very young learners. And those children in foundation reception classes, 5 years old, 6 years old maybe, they quite often like to sing and say nursery rhymes. And out of nursery rhymes can come good science, as you'll see in a moment. But I also thought about Charlotte talking about chunking. And I think nursery rhymes and songs are great examples of how we might chunk pieces of language together in fractional lines. So Jack and Jill went up the hill is a chunk to fetch a pail of water. Jack fell down, there's a chunk, and broke his crown. These are not full sentences, these are parts of sentences. And Jill came tumbling after, and there they are in the picture. So how is science going to emerge from this simple story for young learners? Well, I think all you need is a piece of wood, maybe an old shelf, a book, and you make yourselves a slope. And the challenge for really young children is, well, does it roll? Yes or no? And here we have new words for us for really young learners. Roll, slide, round, flat, move, push, slide, slope. Very easy language to build up. And all I've suggested is that we could have everyday objects and we'll see whether they slide or not. Of course, some things will not roll at all. A banana may not. A ball will. I'm not sure a pear will roll very far. And I think that object on the slope at the moment is not going to roll at all. What about a plastic cup like the one shown? Something very strange happens when you try to roll a plastic cup down the slope. Well, let's think why. Let's look at the cup. Let's see if we can understand why the cup does not roll in a straight line. And there is some science dialogue that you can listen to, because children will be able to explain the reasons to you, particularly if they're working in a group. So that's a little piece of science. It's to do with forces, and it emerges from very young children's work. Okay, back to level 3. Here is an image from the TPK, the Teacher Presentation Kit, and it's one of the flashcards that's available in the TPK. And I've taken it because it does link to the idea of forces and slopes. Now, the image that you'll find in the TPK is just the one that you see. What would you do with this image as a teacher? How could you use it with your children? Have a think about that. Here's an idea that I'll share with you. You could add, as I've done with simple annotations, add some dialogue boxes. And the voice says, Nadia, why does the car move more slowly? And of course, what you're doing is not telling an answer, you're actually encouraging the students to be drawn into the dialogue. Let's just think about what's going on here. What do you think, boys and girls? And there you have an opportunity for you to rest and for your children to chatter away about science. Live longer, stay younger. Get the children to do the work. So let's ask everyone. So that's an example of how I might use the TPK image. Here's another example. Hey Sam, we've got our first results. Let's see what happens if, well, we're going to change something. And this leads me to how you could use this in school or even at home. So here's something in my living room, a box of tissues, a piece of old wood, and I've just put a piece of paper down the side and put some measurements in centimetres along, and there's a ball and you can see the end of a measuring tape. And you can probably see what the investigation is here. It's a piece of science inquiry. And good inquiries have questions like this. They have two parts to them. What happens to blah, 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 blah if we change blah, 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 blah? So the question might be, well, you can see if you can get there before me. What happens to the distance the ball rolls if we change the place we release it from? And we could repeat our measurements, and that's very good science, and it's easy to do, and it's cheap, and it's brilliant science inquiry. And do you know, I don't know the answer, and neither do you. And that's the beauty of finding out together. Of course, later you could change the steepness of the slope, and with children they could change all sorts of things, even do it on a different sort of floor surface. That's for later. But let's just enjoy the simplicity and beauty of a simple piece of science inquiry. So there you are, that's what you may say. What happens to the rolling distance if we change the start height? Now, of course, science inquiry comes alongside and brings with it a series of additional skills, like learning how to make measurements, learning how to put your measurements into a results table. And here's a table which has been scaffolded for children, showing them one of the drawings, one of the directions, so the distances, and of course indicating where the other distances might go. So that's a piece of scaffolding, and we quite often do that in math science by giving the first of a series of results as an example. So yes, planning a table and placing results on a table is a skill. Of course, alongside that skill is the skill of placing your results on a two-dimensional graph. Much harder, a higher level skill, but nevertheless, it can be done with the teacher's support as maybe even a whole class graph. We walk along the height line and we find 25 centimeters, there it is. And then we climb up the ladder of distances all the way to 70, which is tricky because there isn't a 70 on the chart, but it's halfway between 60 and 80, as we know. And there's our measurement turned into a point on a piece of paper. And at primary schools, we do expect children to leave primary schools being able to have seen how to make a chart or a graph. You could make this into a bar chart if that's easier for your children. Is there a shape to all of your results? Can you change the release height? What happens to the distance rolled? I don't know the answer to this. I haven't done the whole experiment. I'm leaving it to you. Is it a straight line? Is it a curve? I really don't know. And it doesn't matter if you as a teacher don't know. In fact, it's better if you don't know, because then you're learning together. Many teachers don't like the idea of science inquiry because they feel a little bit exposed. Oh, I don't know what's supposed to happen. What's supposed to happen? Well, I'll tell you, what's supposed to happen is what happens. So be there as it happens and learn with the children. Nothing's going to go wrong in this experiment. You'll just get some results and you'll learn together. And you'll be able to tell the story of the rolling ball. You'll be able to answer the question, what happens to the rolling distance if we change the start height? To support this sort of work, you'll also find in the TPK sheets like this, which encourage children to think about science questions. If they're looking at something like sliding down a slope, can we find a question that we might be able to answer? Well, how about these as examples? Is that a good question? Are some shoes more slippery than others? Yes, of course it is. Are boys' shoes more smelly than girls' shoes? Well, you may have an opinion on that, but this is not going to be an experiment that's going to give you an answer to that question. So not all questions are suitable. So there's a skill, asking the right question. And the TPK sheets will encourage your children to engage in thinking about good questions. I'm going to finish off with an experiment which I'm going to do with you here. It's another one to do at home, and it's one that is very easily done, and it involves glasses and a candle. Now, of course, there has to be a little health and safety warning here with candles, but provided a responsible adult is nearby, there's not a problem with a child and a candle, providing the candle is well supported on a low base. So I'll show you the sort of candle I've got in my office now, and we can have a look at this experiment being done. We're going to do it together, by the way. With a measuring jug, you can fill up these glass vessels and find their volume. And you may have a series of numbers like this. And children can easily do this. They've been working with water and pouring it into objects since they were 5 years old. So you can measure the volume of water that would fill each of these. And of course, it's the same as the volume of air inside. So once you've measured the volumes and you've dried everything off, that's one set of results. And what we're going to do is we're going to take a glass and we're going to cover the candle, and we're going to start a clock, and we're going to measure the burning time, and we'll have an inquiry question which you can think about. What will the question be? Well, I'm going to do that now just to demonstrate in my office at home. So I'm going to move the camera and let's see if we can observe what we have on the tape. Now here we have, I think you can see that. On my table I have a number of glasses from downstairs in my kitchen, and I have a candle, and I have a measuring jug and a supply of water. I'm going to use only one of the glasses. We'll choose this one here, which is a large, super large wine glass. Well, if you have a watch or a phone with a clock, a stop clock in, you may wish to start your stop clock with me, and if not, doesn't matter. If we haven't got enough time, I'll do the timing, and I'll tell you how long it takes for the candle flame to go out. Now, I don't know whether you can see the flame from where you are. Let's see if I can get a wee bit closer. There's the flame. Okay. I'm going to start in 3 seconds, 2 seconds, 1 second, now. Still burning. 5 seconds, 6, 7, 10, 11, 12. And it's out. 12 seconds. So I have here a graph. And it's a chart with volume of glass along the bottom and burning time along the vertical axis. And it's the candle and glass experiment. I'm going to put a result on this graph, but firstly I'm going to measure the volume of the glass. And I'm going to do that by completely filling almost to the top. I don't want to spill anything. There we go. So that's 1 glass full of water. And I'm going to pour it in the measuring jug. And you won't be able to see this probably. Well, it's about, I know this is not exactly horizontal, 300 millilitres. So that was 300 millilitres. Go back down to our graph. 300 millilitres. Volume, that's here. And 12 seconds burning time, which is down here. So I may have to revise my graph here, but I have a point on the graph. That's the important thing. Now I have some larger volumes, and we can have even larger volumes as well with great big glass mixing bowls, or we can have smaller volumes, small cups like this. The idea is that it's something that you can do at home, which is very simple to do and not too dangerous. Now, before I finish, it's me again, I have a challenge for you. And the challenge, oh, sorry about my microphone being impacted by the movement. This is my final challenge. I'm going to light the candle again. And this time, I'm going to cover it with this lovely mug. And my challenge to you is, how long will it take the candle to burn? Of course, you can't see it because this is not transparent. Haha. But I'm going to tell you the volume of this mug. This mug is 400 millilitres. And I'm going to put it on the candle now. And you don't know whether it's burning or not. But it will only burn for a short time. And your job is to be able to find out how long will the candle remain burning if the volume is 400 millilitres. And the only way you'll find out is by doing the complete experiment and having a complete graph. And from your graph, you can predict the answer to this question. And if I were a teacher, that's the challenge I would set children at home. with the graph. And so there's our graph, and there's the final slide in this piece of work. What were the inquiry skills that I used? Let's think. Did I measure? Yes, I did. Did I record? Yes, I did. In fact, I measured two things. Did I observe? Yes, I observed the candle flame. Did I deal with data? Yes, I dealt with data. And I could even predict a response to the challenge question. Is there a science story here? Of course there's a science story. It involves air and burning and candles needing oxygen to burn, and there being only so much oxygen in each of the containers. And the more oxygen there is, the longer the candle takes to burn. So there's a science story and there are inquiry skills there. Hands on, brains on. So where have we been on this little journey of ours? I wanted to talk to you about your own professional development, about the value of children's voices and the importance that you have to see of listening to children. Remember, you're not alone. You have a complete family of support materials should you choose Max Science in your schools. And with blended learning, the TPK becomes very powerful. And finally, I talked about the joy of finding out together. And it is a joyful thing to do. And it can be done with very young children, and it can be done with very simple equipment. And it can be extended into graphs and charts if you want to. But don't worry about not having the right or wrong answers, because who knows what you're going to discover. The world is out there for you and your children to discover. Just have fun. So that's the end of my presentation. Thank you very much for listening, and good luck with your science teaching. I think there may be some questions coming. I don't know whether we have questions emerging. It seems that there's a lot that I've said that seems to have gone down well, so I'm pleased about that. So well done. I hope you'll do these experiments. You probably have already done them, but good experiments are worth doing lots of times. Oh, do you want to know whether the candle is still burning? No? It's gone out, but someone's told me it's 16 seconds. They've obviously done this experiment before. Or is that just a guess? How many books in the series, someone's asked? Well, there are 6 years worth of books. So there's a textbook for each of the 6 years. So it's really 6 textbooks, 6 workbooks, 6 journals, 6 teachers' guides. Oh, the 16 seconds was a guess. Well, that's a pretty good guess. I think it will be more than 12. And proportionally, I think 16 is a great guess, but you have to do the experiment just to make sure there's not a twist. I'm sure Rona would be able to answer the question about the TPK. Yes. Thank you very much, Rona. Okay, I think it's time to hand back to Rainer now, and I think we're going to have just another short break because you've got the joys of Charlotte's second presentation coming your way very shortly. So without any more questions, I'll say thank you and goodbye from me. Hope to see you again sometime.
Max Science Primary. Discovering through inquiry is a highly engaging and Max Science Primary. Discovering through inquiry is a highly engaging and effective print and digital scheme based on the most successful teaching methodologies used in world science today. Over 6 stages, Max Science Primary introduces students to the key concepts and topics of primary biology, chemistry, and physics with carefully scaffolded resources that build knowledge and confidence throughout the course. The Max Science Primary series features 100% match to the Cambridge Primary Science Curriculum Framework, integrated scientific inquiry and critical thinking skills, materials that are international in content, flexible and adaptable for all global regions, English language support across all resources to support teachers and learners whose first language may not be English. Written and designed by leading science educators, the student books form the basis for active, inquiry-based classroom learning. A Max Science lesson is based upon 3 key themes to stimulate creative scientific thinking. The first stage begins with orientation. Students identify and understand: why are we doing this? What do we want to find out? Why is this important? Next is the exploration stage. Students have the opportunity to explore, experiment, and investigate and test out theories. The final stage is accommodation. Students will discuss what they have found out, what they have learnt, what do they think would happen at the start of the lesson. The Teacher's Guide comes with full support to help teachers plan and deliver active, engaging, and productive lessons, giving guidance on assessment and differentiation. Each topic includes a section on potential scientific language challenges students may face. Full answers to all activities are also provided. The workbooks are designed for extended practice and consolidation in class or at home, where the learners are able to express and record the development of their scientific thinking through carefully thought out games, quizzes, questions, and activities. The workbook pages are clearly cross-referenced with the corresponding stage in the student books. The journals provide a unique way to engage parents in their child's learning, as well as providing the opportunity to consolidate their classroom learning at home through reflective practice. They are packed full of engaging practical activities that not only back up the scientific concepts introduced in the classroom, but also show how science is all around us all the time. The Teacher's Presentation Kit offers a suite of easy-to-use materials for interactive whiteboards or projectors. It includes a digital version of the student book, enhanced with scientific language activities for front-of-class teaching, as well as a packed resource centre full of activity sheets that can be downloaded and printed for whole class engagement. These help focus on the development of scientific skills, word cards and audio glossary for scientific vocabulary learning, and teacher's notes and full answers are included for all activities. Simply visit our website to access all online resources.